There are 5 different types of coma. Each has distinct ways of blocking arteries, which suppress the blood traveling to the brain, which decreases the oxygen given to the neurons. Although the way that oxygen is being depleted differ, the effect it has on the neurons is the same.
This process affects the precuneus area of the brain, which in turn causes a coma. This is because the precuneus requires the most oxygen to control self-consciousness, perception, taking in experiences, and self-processing operations. As less blood is being released into the brain, it trickles to the capillaries.
When blood reaches the capillaries, it changes shape from a plate to a cone. In doing this, it obtains a negative charge. This allows hemoglobin inside the blood to release oxygen, which attaches to the blood. It does this because it is fighting the blood for the shared electron. This is an unstable bond. This unstable bond allows the positive ion channels to easily attract oxygen into the axon.
Not enough oxygen is released into the axon. The signaling molecule does not reach action potential. This signals for the amino acids to be released, which are GABA and glutamate. GABA, being inhibitory, overrides excitatory glutamate, which then cannot act as a stimulant to the nerve. This decrease in stimulant tricks the neuron into thinking it needs less oxygen than it actually does, allowing the nerve impulses to continue without a signaling molecule.
Because of the surge of GABA, the neuron tries to overcorrect by depleting the released GABA. If it overcorrects beyond balancing the ordinary function and sufficiently restores the process, there is a secondary response that makes GABA receptors oversensitive to GABA. This allows the decreased GABA levels to maintain a suppressed effect by not allowing GABA to override itself.
This continuous process determines the length of a coma.